Welcome to Module 4. In Module 3, we were learning about PPCs, the production possibilities curves for individuals or for countries. In Module 4, we're going to learn about how two nations or two individuals are going to be able to benefit if they trade. So we're going to figure out how to calculate opportunity costs to produce each good and learn that you might have a limit on how much of each good you can produce on your own. But if you focus on producing one and the other country focuses or specializes in producing the other good, both countries will have net gains. They will have more goods through trading than they could have through producing them independently. A key term when we're talking about trade benefits is specialization. I mentioned this on the first slide. This concept is the idea that if all countries tried to produce everything independently, they wouldn't be very well off. It's very difficult to truly specialize if you're trying to do a decent job at everything. But if one country is very good at producing one good, and another country is very good at producing a different good, they should each specialize. They should focus their resources, remember they're scarce resources, on just producing each of those products and then trade with the other country. And both of those countries will have better access to goods through specialization than if each country had attempted to produce everything all by themselves. A key assumption with trade benefits is that the trade itself must be voluntary. That means that both parties or both nations must willingly take part in this trade. It must be without coercion. Coercion means that there's no force, maybe military pressure, that makes them do this. If America took over Mexico and then dictated trade terms between those two nations, that would not actually be mutually beneficial for both nations. Theoretically, it would benefit the nation that had the power, and the nation that didn't would be worse off because those trade terms would be through coercion, not voluntarily reached. So voluntary trade is good for both nations because it's going to give people more choices. There are certain products that we don't produce in America or that we don't produce well because our climate doesn't suit itself to some resources and things like that. So there's some things that we gain through trade that we couldn't do well ourselves. And also sometimes we have access to lower prices if it's produced more cheaply somewhere else. So voluntary trade creates wealth, it creates benefits for both nations involved. Why do nations trade? Sometimes nations lack the factors of production that they need to produce certain goods. So remember, the factors of production are land, labor, capital, and entrepreneurship. In terms of land, a good example is Japan. Japan is an island nation, so they have limited amounts of land. A lot of the land that they do have is volcanic, so it'd be difficult to grow crops on. So they might focus on certain types of goods and trade with another country that maybe is able to grow more food, and both countries would benefit. Other countries lack labor. If they perhaps had a war or disease or something like that, they would limit their labor pool. And other countries lack capital. So there might be some sort of new innovation, a new technology, that if your country is technologically behind, then you would want to trade with a country that had those advances, and maybe you could produce food or clothing or something else that they might need, and both countries would be better off. Now, usually, people decide to buy something for a price reason. So a lot of Americans buy goods made in China because goods made in China tend to be cheaper. Now, number two is saying that people may prefer products made in other countries for non-price reasons. So in this case, they're actually more expensive, but there's something about that good. Maybe it's hard to get, or the quality is just so good that people will pay more for it. Some examples here would be Cuban cigars or Cuban coffee, Italian leather, Egyptian cotton, Mexican avocados. There are lots of goods that are produced in certain parts of the world and are therefore very exclusive, and the quality is very good. German engineering, Swiss banking, there's various things like that that you might associate another country with a certain quality, and therefore people will pay more for that good for that reason. Before we get too far along in discussing trade, I wanted to make sure that you're completely caught up on these trade terms. A lot of these you might already know, but just in case, I wanted to make sure that we're clear on what these terms mean. So the first trade term are imports. Now, all of these are going to be from the perspective of our home nation, so America. So an import would be a foreign good or service that is purchased from another nation. Now, a service that you might buy from another nation is maybe you are trying to take a trip to Russia and you're using a Russian travel agent to book that for you. So that's a service that someone in another country is providing. That would make it an import. Exports are domestic goods. Now, this word domestic always means home, your home country. So it's kind of the opposite of foreign here. So you're going to import countries from other nations, foreign goods, and you're going to export domestically produced goods and services. So things that are produced in America can be exported to other nations. Those are our own products. Now, with imports exceed exports, that means that we're actually buying more products from the world than the world is buying from us. So we have more money going out than we do coming in. And that gives us a trade deficit. That means that our trade is in the negatives, that we have more money going out than coming in. A trade surplus is when exports exceed imports. So that would be if more people are buying our goods, we have more money coming in than money going out purchasing others. America, if you look overall, we tend to have a trade deficit, but sometimes with individual nations, we might be having a trade surplus with them and a deficit with another nation. Kind of a, do you buy more from us or do we buy more from you? It gets a little bit more complicated when we talk about which of these things are good. You might say, aren't trade deficits always bad? Well, remember, very few things in econ are always good or always bad. You might say it's bad that we have a trade deficit with China, but that means that Americans are able to buy goods inexpensively. They are able to use that money on other things, maybe buying services in America because they saved that money. And if all of a sudden we stopped trading with China completely because we have a trade deficit, think how much that would hurt American consumers that are below the poverty level. It would be very detrimental to them. So again, remember, it's a little more complicated than this is good or this is bad. So a trade deficit, imports exceed exports, and a trade surplus, exports exceed imports. Now I'm going to introduce two really important macroeconomic concepts when it comes to trade. We have absolute advantage and comparative advantage. The main idea about absolute advantage is that the country can produce more. So it's very straightforward. You actually don't have to do any math for absolute advantage. You can just look at a table and see which country is producing more of that good, or you can look at the PPC and see which country is producing more of that good or service. Now, for absolute advantage, it is possible to have the absolute advantage in both. That's what AA stands for down here, shortened. So if we're looking at bikes and computers, maybe one country can produce both. That's perfectly possible. Now, even if a country has absolute advantage in both products, that actually doesn't tell us what they have comparative advantage in. So, absolute advantage, you look at the raw numbers, and whoever can produce more has absolute advantage. Comparative advantage, you must calculate the opportunity cost. So, if we're looking at bikes and computers again, we're going to have to figure out the opportunity cost of each nation producing one of each of those goods. So nation A, if they produce bikes, they're giving up this many computers, and nation B, if they're producing bikes, they're giving up this many computers. We're going to see who is giving up the least amount of the other product they have a lower opportunity cost. That gives them the comparative advantage. You actually can never have CA or comparative advantage in both. It is impossible, which might strike you a little bit strange. Why can't one nation be better at both? Well, think about it like this. If you produce more of both, that means in order to make one, you're actually giving up more too. If you're really amazing at everything, that means that in order to produce more of something, you're giving up a higher number of the other good. So we're going to do a lot of math and practice these concepts. So just for now, as long as you understand that absolute advantage is the bigger number, and you may have absolute advantage in both. Comparative advantage is who has a lower opportunity cost. So you must do math to figure out comparative advantage. It is not possible just to look at tables and figure this out. Whoever is giving up the least of the other product, they have the comparative advantage. And you can only have CA in one product. So once you know which country has comparative advantage in one good, the other country has to have it in the other product, because you can never have comparative advantage in both. Last slide, we learned the comparative advantage is when a nation has a lower opportunity cost in producing that good. So whichever good you have a lower opportunity cost in is your comparative advantage, and that is the good that the country should specialize in. And the other country, because they will have the comparative advantage in a different product, they should specialize in producing that product. So as long as both countries are producing goods which they have comparative advantage in, that means they're producing it with the lowest opportunity cost. They'll each specialize in those goods and trade for the other goods. Both countries will be better off. On the next slide, we're going to actually practice how to figure out per unit opportunity cost with just one nation. Then we'll start doing it with two nations in order to compare. So let's practice per unit opportunity cost. Remember, anytime you decide to produce more of one good and less of the other good, there are trade-offs. But the opportunity cost is per unit, meaning that for every one you decide to make, what is the exact number of the other good that you're now unable to make? So in this example, suppose total maximum in one day, you could produce either 5 t-shirts or 10 hats. Remember, it's not possible to make the maximum amount of both. So if you're making 5 t-shirts, that means you're making 0 hats. And if you're making 10 hats, then you're making 0 t-shirts because you're focusing just on those goods. So if we decided to make one shirt, what is the opportunity cost in terms of the amount of hats that we're giving up? So the answer is 2 hats. And how you set this up is you rewrite the total maximum productions like a ratio. So you see, I wrote 5 shirts and 10 hats because that's the maximum you can make of each. So if you wanted to make 5 shirts into 1, you would divide both sides by what number? By 5. Because then the 5s cancel out. So we have just one shirt, and 10 divided by 5 equals 2 hats. So to make one shirt, we're going to give up the ability to produce 2 hats. On the other side, if we wanted to make one hat, how many shirts are we now unable to make? What's our opportunity cost? That is a half a shirt. So again, I rewrote the exact same ratio from above, but I just put the thing that we're making on the left side. That helps, I think, make it simpler to see which one you're doing. So if 10 hats equal 5 shirts, and we need to figure out 1 hat, we should divide both sides by 10. So that cancels out. We only have 1 hat, and 5 divided by 10 equals 1/2. That would be the opportunity cost for each hat that you decide to produce. Now that we figured out per unit opportunity cost for one person or one country, we're going to look at how you do this for 2 individuals or 2 nations, how you're going to figure out absolute advantage and then comparative advantage from all of those numbers. So at the top, we have two people, Ronald and John. They're each going to be producing either pizzas or burgers. Ronald can produce 20 pizzas or 200 burgers, and John can produce 100 pizzas or 200 burgers. So what is Ronald's opportunity cost for one pizza in terms of burgers given up? So for Ronald, we're only looking at his numbers, 20 pizzas and 200 burgers. So this is how we set it up. On the right, you can see the ratio for Ronald is 20 pizzas to 200 burgers, and I always put the good on the left that we're trying to solve for. So if we're trying to figure out one pizza, for every one pizza, what's the cost? So you put 20 pizzas on the left. In order to make that into one pizza, you're going to divide both sides by 20. That will cancel out pizzas. So we have one pizza equals 200 divided by 20. Now remember, you're not going to be able to use a calculator here. So it's very important to start being able to count your zeros. So if we cross out 1 0 here and 1 0 there, is it easier? 20 divided by 2 equals 10. So that we know. So for every one pizza that Ronald makes, he's giving up the opportunity to produce 10 burgers. Go ahead and pause this here and see if you can set up the equation and solve for number 2. So pause it and we'll go over the answer in a moment. All right, so for this one, we're going to use the same 20 pizzas and 200 burgers, but we're going to switch the order around because we're solving for burgers. So 200 burgers on the left. We're going to solve for burgers, so we want to divide by 200 to cancel out both sides. And then 20 divided by 200, again, might be a little bit hard, but if you cross out some zeros, 2 divided by 20 equals 1/10 pizza. Now, I don't know if you're starting to see at this point that opportunity costs are always going to be reciprocals, because we're just using the same ratio and switching them around. So one pizza equals 10 burgers, or one burger equals 1/10 pizzas. So that's a great way to check your work and make sure that you're doing it right. Go ahead, we're going to do John next. See if you can set it up correctly on your own. And remember, for John, we're going to look at John's numbers. So don't use the 20 and 200 again. John has different numbers. So set it up for one pizza, and we'll check your answer in a moment. Pause the video. All right, so for John, he can make, we're solving for pizzas, so 100 pizzas or 200 burgers. We're going to divide both sides by 100. 200 divided by 100 equals 2. So one pizza equals 2 burgers. We just learned the rule about reciprocal, but go ahead and do the work and check it for John and one burger. So pause and do the work for number 4, please. All right, here comes number 4. Yep, one pizza equals 1/2. One burger equals 1/2 pizza. So we're going to put burgers on the left. We're solving for burgers. Divide by 200. 100 divided by 200 equals 1/2 of a pizza. All right, so you have done opportunity costs for all 4 questions. Now, number 5, do you remember what absolute advantage means? Do we have to do any math for absolute advantage? Okay, no, we're just looking at the total number. So we're going to look up at the top of the question here and determine who has the absolute advantage in each. So for burgers, who can produce more burgers? Now the answer is neither. And you want to be careful here. Don't say both. It is impossible for 2 people to have the exact same advantage over the other. Think about it. That doesn't make any sense. So if they each make 200, that's a tie, and a tie is not an advantage. So neither has the advantage in burgers. That's possible. Our rule for absolute advantage is that it's possible for one country to have AA in both. But it's also possible for neither country to have an absolute advantage in one good if they both have the same number. Now let's look at pizzas. Who has the absolute advantage in pizzas? Well, John does, because he can make more. 100 pizzas that John can produce is more than 20 pizzas Ronald can make. Simple enough. So, absolute advantage, we don't do math, we're just looking at numbers. Now, comparative advantage, they make all these marks go away. Comparative advantage, we're looking at who has the lowest opportunity cost. So for the production of burgers, we're actually going to simplify and only look at burgers. So here's one equation for burgers. Sorry, with the cursor, this is very hard to circle. And the other equation for burgers. So I wanted us to kind of highlight in on what we're looking at. So who has the lower opportunity cost? Ronald does. Now this is the case where you're going to actually have to get pretty good at comparing fractions and knowing which fraction is the smaller fraction. So 1/10 is smaller than 1/2. So if Ronald is only giving up 1/10 of a pizza, he's giving up less for every burger he makes. Therefore, he has the comparative advantage in burgers, and he should make burgers. Okay, I'm going to make this all go away, and we're going to look at who has the comparative advantage in pizza. So let's look just at the pizza equations. So we have one pizza equation there, one here. Okay, so who has the comparative advantage in producing pizza? John does, because he is only giving up 2 burgers. That is a lower opportunity cost than Ronald, who has to give up 10. We also learned the rule here that you can never have comparative advantage in both. So knowing for number 7 that Ronald had comparative advantage in burgers, that tells us that John has to have comparative advantage in the other product. It is impossible for him to have it in both. But I just wanted to show you how you can look at the numbers, especially if you're maybe a little bit rusty on fractions and you weren't sure 1/10 and 1/2 which was smaller. You can definitely see here 2 burgers is less than 10 burgers, and then go backwards from there. Well, if John has the CA in pizza, Ronald has to have it in burgers. And remember, whoever has the comparative advantage, they're the ones that should produce that good and then trade. So that was an example with 2 individuals. We'll do some practice with countries next. Now let's practice doing comparative advantage, absolute advantage, and figuring out trade through looking at a PPC. So here we have 2 different countries, USA and Brazil, and they're each producing 2 goods, sugar and wheat. So looking at just these PPCs alone, who has the absolute advantage in sugar production? USA does, because they can produce 30 tons of sugar and Brazil can produce 20 tons of sugar. So USA has the AA, the absolute advantage in sugar. How about wheat? USA can produce 30 tons of wheat, Brazil can produce 10. So USA also has absolute advantage in wheat. They have AA in both. And remember, that is okay, but you can never have comparative advantage in both. All right. Let's use this chart to fill out the opportunity costs for each of the goods. So for USA and wheat, first of all, we're going to set up our equations. And remember, for USA and wheat, we're going to do 30 wheat when the ratio is with 30 sugar. So either way you set it up, 30 sugar, 30 wheat, 30 wheat, 30 sugar. What's nice is that 30 divided by 30 or 30 divided by 30, either way, it's always going to be 1. So if the number is the same for both goods, you're going to have an opportunity cost of 1. So USA sugar, 1 sugar equals 1 wheat, and for wheat, 1 wheat equals 1 sugar. 30 divided by 30 is going to be 1. Simple enough. Don't have to set up the equation multiple times. Now remember, you can't just write 1 in the box. That would be wrong. Opportunity costs are always in the other good that you're giving up. So opportunity costs are not just a number. They're a number of the good. Gotta have the good. Okay, so for Brazil and wheat, we have 10 wheat from our table. We have 20 sugar from our PPC, so 10 wheat, ratio 20 sugar to divide both sides by 10. So you cross out the wheat, you're left with 2 sugar. So 1 wheat equals 2 sugar. Now, you can either redo the ratios to get the new one, or you can remember our rule, reciprocals. So if 1 wheat equals 2 sugar, then 1 sugar equals half a wheat. Or you could just draw the whole thing over again and say 20 sugar equals 10 wheat, divide both sides by 20, and you're going to get the same answer no matter what. Our reciprocal rule still applies to the US because 1 divided by 1 is still 1. So ratio-wise, our rule still applies. So we've gone ahead and filled in the chart with the opportunity costs of each good. Now we're going to see how we can answer the questions from that. I still have the table at the top here because this is what we need. The PPC won't actually tell us the answers to these questions. The PPC only shows us absolute advantage. Trade is all about comparative advantage, and you've got to do the math for that to work. Okay, so looking at this picture, which country should produce wheat? So we're looking at the wheat column. USA gives up 1 sugar, Brazil gives up 2 sugars. The lower opportunity cost has comparative advantage. So USA has a lower opportunity cost. They're only giving up 1. Brazil's giving up 2 to produce wheat. So the USA should make wheat. Now, a common mistake that people will make is they look at Brazil and say, oh, Brazil, half wheat, wheat's lower. No, the cost is lower, and the cost is in the other good. So for this wheat column, who is paying the lowest cost in the other good? USA is. They're only paying 1 sugar. So they're producing wheat. Who's doing sugar? Who has the lowest cost in terms of wheat? Brazil does. So in order to make 1 sugar, they're only giving up half a wheat. They should make sugar. So that's simple enough. Now we're going to take it one step further and talk about exports and imports. So if you're exporting sugar, the question is, are you making it or is the other country making it? For an export, you're making it. And we just said that Brazil was the one that should produce sugar. Therefore, Brazil should also export sugar to the other country. So for importing, are you making it or is the other country making it? The other country's making it. So we just said that USA should produce wheat, therefore Brazil should import wheat. USA will make it, Brazil will import it from the US. Up until this point, all of the comparative advantage questions that we've done have been output questions. When you get an output question, you're given the maximum amount. So when you saw how many pizzas or burgers, how many hats or shirts, that's the maximum amount. Those are all output questions. So output questions, because they're already giving you the maximum amount, absolute advantage is going to be the largest number. Who can make more? They have the absolute advantage. Now, the way that you set up the equations for comparative advantage is actually going to be totally different if it's an output question or an input question. So I'm going to teach you a trick for how to set up each equation, and then we're going to practice both output and input questions to see how this works. So for output questions, the mnemonic device is OOO, which means an output, the other goes over. And the other that we're referring to is going to be the other good that that country can make, not the other country. So other is the other good. Now, input questions, we haven't seen any of those yet. An input question is going to show you what goes in to making the product, the good or the service. So it could be, how many hours does it take to make it? That's an input question. Or how many workers go in to making it? Again, input. So what's going to be different about input is that we have a different equation. First of all, an input is going to be IOU, input, the other goes under, and we'll practice that soon. But the other big difference here is that, remember, you never do math for absolute advantage, but if it's an input question, the absolute advantage is a smaller number. So if I'm telling you that I can make a hat in 3 hours and George can make a hat in 5 hours, whoever can make it in the least amount of time, that's better. So for hours, an absolute advantage is a smaller number. If I said it would take me 5 employees to make a shirt and someone else could use 2 employees to make a shirt, then they're using a smaller number of workers. So that's the absolute advantage. So before you do anything, you have to determine output or input. And that's going to change both absolute advantage and how you set up the equations for these things. Okay, we have a question here about Japan, Canada, and their production of CDs and beef. The statement above the table says, the following chart illustrates the number of CDs and pounds of beef that can be produced in 1 hour. So the question is this an output question or an input question? Now this can be a little bit confusing because you're both given total numbers in the table, but the question did mention time. It said 1 hour. So how do you know if it's output or input? What you do is to determine which one is the thing that's the variable. Is time what's changing, or is the total number what's changing? So in this case, the time is stable. They each have 1 hour. And what's changing is the total number that they're producing. Therefore, this is going to be an output question. Now, looking at the table, you also know that the table is giving you a total number and is not giving you opportunity costs, because if the table only says 4 and it doesn't say for beef, then it's got to be the output, the total number they're giving you. If it's an opportunity cost, it would have the other good. Okay, so the next thing that we're going to do is try to draw a PPC from this table. You were given an L-shaped bracket in your notes, so it looks like the one you have on the left here. And first you want to go ahead and draw in the goods. So please put CDs on one side and beef on the other. It doesn't matter which axes you use to draw each, as long as you're consistent. So we have CDs on one and beef on the other. The maximum number of any good here is 6. So I have 6, 4, 2, 2, 4, 6, and they're approximately evenly spaced. Now, before you draw on the countries, I wanted you to see kind of the way we've done it before and then a shortcut. So don't draw in the countries just yet. Please just label the axes and the numbers. Okay, now look at the bottom. I filled in Canada and Japan. And you have to label which country is which, because just drawing lines without saying Canada or Japan, no one could tell which was which. So, looking at the table, Canada can make 4 CDs, so we started here, or Canada can make 6 beef. And then Japan can make 4 CDs and 2 beef. So that's one way to make 2 different models with 2 different countries. But here's the shortcut. So up here in the top right, I did both countries in the same model. This is what I would like you to draw in your notes. That's why I only gave you one L bracket. Because each country has the same goods, you can draw them both together. So we still have the same numbers. Japan is doing 4 CDs or 2 beef. Canada is doing 4 CDs or 6 beef. But it kind of saves space. It's more efficient to draw them both together. But no matter which way you draw them, you have to label which curve belongs to which line. Now, to be completely clear, we've learned earlier about increasing opportunity costs and constant opportunity costs. CDs and beef. Is it going to be easy or hard to switch between production of those goods? It's going to be hard. So in reality, those should be increasing opportunity costs, so the line should be more curved. In order to do a trade demonstration, in order to do 2 countries like this together, you are able to simplify it and do straight lines. As long as you were asked the question of, would it be increasing or constant? As long as you at least know this would be increasing because the goods have very different resources, then you're okay. Alright, now that we've drawn the PPC that goes to the table, and we've determined that it's an output question, let's go ahead and answer the questions about it. So number 1, which nation has an absolute advantage in producing CDs? Since this is an output question, are we looking for the bigger number or the smaller number? Alright, the bigger number. So, who has an absolute advantage in producing CDs? Neither of them do. If they have the exact same number, neither one of them has an advantage. And you can look at either the table or the PPC to see that neither one of them has the advantage in CDs. Now, how about in beef production? Looking at the PPC or the table, which country has an absolute advantage for beef? Canada does. They simply can produce more. All right, now we're going to use this new equation that we learned, the OOO, which is output other goes over. Okay, so for which nation has a comparative advantage in producing CDs? We're going to actually need to do the math for both countries. So we're going to figure out Japan's opportunity cost for CDs and Canada's opportunity cost for CDs. And I'm going to walk you through how this all was set up. So we're going to do the equations first, and then we'll reveal the right answer. Okay, so Japan CDs, other goes over. Okay, so we're looking at Japan and CDs, or Japan and beef. For Japan, the other is the other good Japan cannot produce. So if Japan's making CDs, other is beef, and other goes over. So that's why the 2 for the beef, the other goes over the 4, which we can simplify. 2 divided by 4 equals 1/2 beef. And remember, you must write the other good for opportunity cost. So for every CD that Japan chooses to make, they are foregoing the ability to produce half of a beef. All right, now Canada CDs. For Canada, if we're looking at CDs, other goes over, the other is beef. So 6 goes over 4. 6 over 4. That simplifies to 3 over 2. Now you might say that simplifies to 1.5. Also true. I'm keeping it 3 over 2 just to kind of reinforce the reciprocal rule. We'll see that in a moment. So if Canada gives up 3/2 of beef and Japan gives up 1/2 of beef, who has a comparative advantage? For comparative advantage, do we want a higher or lower opportunity cost? We want lower. So Japan's giving up fewer beef than Canada, so Japan should make CDs because they're giving up less to do so. Okay, I'll scroll a little bit here. So for producing beef, next one. So we're going to have to do Japan and Canada again to figure this out. Now you might know, wait a minute, I've learned the rule. If Japan has a comparative advantage in CDs, then Canada's got to have it in beef. And you're right, but let's go ahead and prove it just for extra practice with our new equation. So Japan and beef. So for Japan, beef, the other is now CDs, and other goes over. So 4 goes over 2. So what we have here, simplified to 2 CDs, which again, here's our reciprocal rule. If it's 1/2, this one is going to be 2 for that one. The reciprocals apply. For Canada, beef, so Canada beef, other 4 goes over 6. 4/6 simplifies to 2/3 of a CD. Now, who is giving up fewer CDs to produce beef? Canada is. They're only giving up 2/3, whereas Japan's giving up 2. So Canada has the comparative advantage in beef production. So we're seeing a lot of our rules playing out here. We're seeing that if you have a comparative advantage in one, you cannot have comparative advantage in the either. And we're seeing that our opportunity costs are always reciprocals of each other within the same country. Okay, now just another way of asking the same question. Should Japan specialize in CDs or beef? We said that Japan has a comparative advantage in CDs, therefore they should specialize in CDs. Canada has a comparative advantage in beef, so Canada should specialize in beef. All right, before we do anything with example 2, I want to point out the fact that the numbers in the table for this example are the exact same numbers as in the last example. So we have 4, 4, 2, and 6. And I did that on purpose because these are both different types of questions. And I wanted you to see how you can get the same numbers, but if you answer the question like it's the opposite type, everything's going to be wrong. So be very aware that to decide if it's an input question or an output question before you go anywhere. Okay, looking at the table that you were provided with, you can't actually tell if it's input or output. So it's very, very important to read the statement above the table. In this case, it reads, the following chart illustrates the number of hours it takes to produce 1 loaf of bread and 1 bushel of corn. So in this case, they're each producing 1 unit of bread and 1 bushel of corn. That's not the variable. The variable is time, number of hours. That's what makes it an input question. I know I kind of gave it away in your worksheet, but I wanted you to see how you can determine that it's an input question. Now, when you're drawing an input question on a PPC, There's one major difference, which you can probably see by looking at it. So we still have one good on each axis. We've labeled the numbers here. We've drawn in. You still can draw both countries on the same PPC. That's fine. But the major difference for input is that if this is about time, you must have time labeled, because otherwise someone could look at your PPC and think that they're each producing 4 units of bread, and they're not. This is saying that it takes each country 4 hours to produce 1 loaf of bread. It takes the US 2 hours to produce a bushel of corn, and France 6 hours to produce a bushel of corn. So you label it just the same, but you must include time. That's the only new thing here. Okay, so once you've drawn your PPC, and again, you could draw 2 different ones, one for each country and label the country at the top if you'd like, or be more efficient, draw them on the same model. Either way, you want to make sure that you have time included. And if you're drawing 2 side by side, definitely put bread on the y-axis for both and corn on the x-axis for both. Just be consistent. Oh, one more tip. If you're drawing 2 side by side, you want them to be symmetrical. So for example, it should be obvious that US is smaller here than France. They shouldn't be drawn like they're the exact same size. Okay, let's go ahead and do some of these questions. So which nation has an absolute advantage in producing bread? For absolute advantage, do you need to do any math to answer that question? No, we're just looking at the raw numbers. But for an input question, do we want absolute advantage to be the larger number or the smaller number? Smaller number. So looking at bread, you can look at it on the table or on the PPC. Which country has an absolute advantage in bread production? Neither of them do. They're both tied. It takes them each 4 hours to produce 1 loaf of bread. No benefit there. Now, who has an absolute advantage in producing corn? You can look at the table or the PPC. The answer is the US. So if you misread this question, if you were going too fast and you were thinking, oh, absolute advantage is the bigger one, you would say France and you would get this one wrong. So let's explain why this is true. Remember, absolute advantage, if it's input, it's who can produce it in the least amount of time. Isn't it better to take only 2 hours to make a bushel of corn as opposed to 6 hours? Yes, absolutely. So for input, absolute advantage is the smaller number. 2 hours is better than 6 hours. So you want to be thinking through and not go too fast with these. All right. Now we're going to do comparative advantage, and we're going to use our new equation, IOU. In input questions, other goes under. So this is going to be different. And we're still going to look at it. So for bread, the US and bread. The other for the US, remember, other always means the other good, not the other country. So US bread. The other is corn, but it goes under. So we have 2 going under their number. So 4 divided by 2, you can simplify to 2. So for every 1 unit of bread, they're giving up 2 corn. France bread, other is 6. It will go under. So 4 divided by 6 equals 2/3 corn. Now, one thing that we haven't talked about yet. For comparative advantage, you set up the equations differently if it's output or input. But once you've set them up, we already learned the rule about comparative advantage, that whoever gives up the least has comparative advantage. So that's the same no matter what type of question it is. You start the math differently, but your answers, whoever is giving up the least should do it. So for every units of bread, the US gives up 2 corn, France gives up 2/3. Who is giving up least? France is. So France should produce bread because their cost in the other good, in corn, is less. Okay, if we know that France has a comparative advantage in producing bread, does that tell us who has a CA in producing corn? Yes, we know that the other country, we know that the other country has to have CA. So if France has CA in bread, US has CA in corn. But let's practice it because it's very important for us to practice these things. Let's get the table. All right, so corn, US and corn. Other goes under. So 2 divided by 4 equals half bread. For France, corn, other goes under. 6 divided by 4, 3 halves. We still have our same reciprocals happening from before. What's smaller, 1/2 or 3 halves? 1/2 is. So the US has the comparative advantage in corn. So this was different for input. This was different from input. That was different. That was different. So I want you all to see that no matter what, the very, very first thing you should do with comparative advantage is decide, is it an input question or an output question? Because everything will follow from that decision. Now that we've figured out how to calculate absolute advantage and comparative advantage and to determine who will specialize and produce each good, and now we need to learn the last part about trade terms. When is trade beneficial? So setting up trade terms is deciding, if I give you one of this good, how much of that good will you trade with me that we're both going to be better off than producing it independently? And these are going to be concrete numbers. And how you do it is you first calculate the opportunity cost for both countries. So in this example, if Japan can produce 1 CD and they have to give up 2 beef, and Canada, when they produce 1 CD, they give up 4 beef, in order to find fair terms of trade, you just pick a number in between. So we had 1 CD equals 2 beef, 1 CD equals 4 beef. Something in between would be 3. So fair trade terms would be if each of them traded 1 CD for 3 beef. So any number between the opportunity cost between 2 and 4 would be beneficial for both countries. Let's try another example, and we'll also take this one all the way out to terms of trade. So you are presented with a table that looks a little bit different than one which we've seen so far. But in this case, they actually just gave you the total number in the table and also left room for you to write the opportunity cost inside that table. So my first question is this an output question or an input question? I told you to look for the statement beforehand, but there isn't one. So which one do you think is the default? Okay, an output question is the default type question. We're just giving you a total number. So in order to draw the PPCs, of course, you could always draw one PPC and have both countries on the exact same model. Nothing wrong with that, but I thought it'd be good to practice doing them side by side again, just to make sure that we're doing a good job with proportion. So for Kenya, they can make 30 pineapples. So you want to label pineapples for both, radios for both, and make sure that they are about the same. So 40 on one should be about the same as 40 on the other, so that these things look proportional. So Kenya, 30 pineapples, 10 radios. India can make 40 pineapples or 40 radios. And I got those numbers from the table here. So once you plug them in, yes, in essence, if it's said to draw it as demonstrating increasing or constant opportunity cost, then these lines should be more curved because it's going to be very difficult to switch between producing pineapples and radios. But for trade terms, we're trying to simplify it so you can draw it as a straight line just for the sake of ease here. All right, now because it is an output question, let's go ahead and start figuring out the work. So Kenya, pineapples, 1 pineapple equals how many radios? Here we have the work. And by the way, I did simplify it a little bit. Kenya pineapples is K-pine. But I find that a lot of you all will end up doing a lot of fractions all over your papers and not labeling anything. And that gets people into trouble really fast. So always label the country and the good that you're looking at. So for Kenya pineapples, the other is Kenya radios. It's an output question, so OOO, output, other goes over. So Kenya pineapples, other, 10 goes over 30, which simplifies to 1/3 radio. And let's go ahead and fill this in our table. So for every one pineapple is 1/3 radio. All right. And then we do know the law of reciprocal, but just for the sake of extra practice, Kenya radios, other goes over. So 30 over 10, one radio is going to be equal to 3 pineapples. All right, very good. So now that we've done the comparative advantage and opportunity costs for Kenya, let's do India. We have 40 pineapples and 40 radios. Yay, we love when they're the exact same number because then the math is really easy. So India, pineapples, other goes over, but 40 over 40 is 1. And the other way around, 40 over 40 is 1. So both of these things are going to be 1. Go ahead and fill in your table as well. All right. Now that we have figured out the opportunity costs, who should produce each good? So for pineapples, who has the comparative advantage, Kenya or India? Are we looking for a bigger number or a smaller number? Okay, giving up 1/3 is better than giving up 1. So this means Kenya has the comparative advantage in pineapple production, and they cannot have CA in both. That's impossible, but we can also just look and see that India only gives up 1 pineapple for every radio they produce, and Kenya gives up 3. So Kenya has the CA in pineapples. India has the CA in radios. Who has absolute advantage? Again, is this an output or an input question? Output question. So absolute advantage should be the bigger or smaller number? The bigger number. Okay. So India has an absolute advantage in both because they produce more pineapples and more radios. So India has an AA in both. So hopefully we're getting better at doing the math, at figuring out how to set up all of these equations. Now we'll practice trade terms with these numbers. All right, you've learned the rule for terms of trade. And the rule is that once you've figured out the opportunity cost for both nations, the trade terms have to be a number in between. So if Kenya can produce 1 pineapple and they give up 1/3 radios, and India produces 1 pineapple and gives up 1 radio, what's a number that's in between 1/3 and 1? Well, there's a bunch of right answers. Don't pick the actual numbers themselves. So don't say 1/3 or don't say 1. It has to be in between, but 1/2 is in between, 2/3 is in between. I'm going to go with 1/2 here, and I'll show you why in a moment. So a fair trade term would be 1 pineapple equals a 1/2 radio. That's going to be good for both countries. For 1 radio, Kenya gives up 3 pineapples and India gives up 1 pineapple. So it's a fair number that's between 3 and 1. 2. That's why I chose 1/2 before, because you want these things to be reciprocals like everything else that we've done so far. So we have 1/3 and 3, 1 and 1 are reciprocals, 1/2 and 2 are reciprocals as well. That way everything kind of lines up neatly and cleanly. If we chose 2/3, that is in between, but you can also choose 2 for this one. It's got to be matched up. All right, so now you know that that fits the rule for trade terms, but we haven't actually proven why that makes a country better off. So number 5 is going to show why this is actually going to be better for both countries, as opposed to each country trying to just make things by themselves. Okay, so we're going to go with what we said was a good answer, 1 radio equals 2 pineapples. Now, we know before that Kenya at maximum can produce 30 pineapples. So let's say they specialize in pineapple production. They make all 30 pineapples. According to these trade terms, 1 radio for every 2 pineapples. So if you're making 30 pineapples, how many radios can they get? 15. The way we did that is it's all a ratio here. So if 2 pineapples get you 1 radio, and we're making 30 pineapples, you divide that by 2 to get 15 radios. All right, so with trade, Kenya can get 15 radios. Without trade, how many radios could they make on their own? They could only make 10. So, is Kenya better off trying to make only pineapples or only radios, or with trading? They're better off with trade. First of all, they can make more maximum. They can make 30 pineapples and now trade for 15 radios, better than they could do on their own. But second of all, it was never possible for them before to make maximum of both. Because remember, if all day long all they made was pineapples, they're only making 30 pineapples and 0 radios. Those two are the opposite extremes based on specializing in just pineapples or just radios. Trade makes them much better off. All right, so we said Kenya was going to produce pineapples. So if India produced radios, India could make 40 radios by themselves. So if India makes 40 radios by our trade terms, 40 radios would get them how many pineapples? It'd be 40 times 2. Whoa, 80 pineapples. So before, they could only make 40 pineapples. They're going to be much better off with trade. So as you saw, one country benefited and the other country benefited more. And that really just depends on what terms you set and which one is closer to. Bottom line, are both countries able to receive and produce more goods with trade than they could by themselves? Absolutely. So the fair terms of trade between the opportunity costs is going to make both countries able to produce more goods than they could by themselves.